Hello everyone. It's Mr. Harrison bringing you a lesson for my pre-calculus students called Binomial Expansion. This is lesson 31 in your book. It's on page 167 if you wish to follow along. Now we've done binomial expansion before using Pascale's triangle, and we're going to learn today. We're going to use it a little bit to begin with, but then learn how we don't need Pascale's triangle to do the work for these expansions. If you're looking in the middle of page 167, it gives you a very involved formula for how you do this. It shows that any term in a binomial expansion equals n factorial over the quantity n minus k plus 1 factorial times the quantity k minus 1 factorial times f to the n minus k plus 1 power times s to the k minus 1 power. What on earth, right? You have no idea what that means. It's actually a lot easier than it looks. Formulas are a wonderful thing, but we need some practical application on how this thing works. Disclaimer. Sometimes when I've been doing these videos, my computer will suddenly ramp up and it sounds like there's a vacuum cleaner going off in the room. It's my computer getting more power or something. I don't know. Sounds like it's about to take off. So I'm going to be doing the examples on page 168. We're going to skip 31.1 for now. We're going to come to it last. And we're going to do 31.2 and 31.3 together. I've got them written up here on the board already. And as I said, we're going to be using Pascale's triangle to begin with to find the first answer. 31.2 says find the 8th term of the expansion of f plus s to the 12th power. We learned last year, in 2019, and even before that, to write up our grid like this. F plus s to the 12th power, we know will, if we were to do it completely out, would have 13 terms. They're not asking us to write out all 13 terms. They only want to know the 8th term. First of all, if you were to go to Pascale's triangle, which you all have on your cheat sheet, but I believe it only goes up to like the 6th or 7th power here, you would be able to find the coefficient from there right away. I've written them down from the poster we have in the back of the room. We know that the coefficient of the first term is always 1. You should know the coefficient of the second one because it's this power here. It will be 12. From there on out, it's anybody's guess. Like I said, you could go and work it out yourself, draw out Pascale's triangle to all these different levels. But that gets kind of tedious, quite tedious. And so, like I said, here in a moment, we're going to show you kind of the quick way to do this. The rest of these coefficients are 66, 220, 495, that's a 4 there, and 792, 924, and how embarrassing, I thought we were only going to the 6th power. I didn't go all the way out. Well, guess what? I know that it starts to go back down again. It's 792 again. So there's our coefficient. What power do these first and second terms go to? Well, I know that this goes 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I'm not drawing out all 13 terms. And that these two powers here must add up to equal 12. The second term, the s, I'm off screen, aren't I? Is 0, 1, 2, 3, 4, 5, 6, 7. There is my answer right there. The 8th term will be 792 f to the 5th power and s to the 7th power. Now, we need to find out, the lesson is about how to find this in an easier way. Well, we're going to start this all over again. Let me just erase these real quick. And we're going to focus on the s first of all. If you notice that when in our first term, the power of the s was 0. In the second term, it was 1. Third term, 2. Fourth term, 3. Fifth term, 4. I'm seeing a pattern here. Okay? That tells me that if I'm looking for the 8th term, my second term in the quantity, whatever it may be, is going to be to the 7th power. You're looking for the 8th term, it's going to be the 7th power. So now I know that my s will be to the 7th power. Now we've already established that here, but I'm showing you how this works. I shouldn't have erased all that, but all of this, I also know that the powers here will always add up to 12. 12 plus 0 is 12. 11 plus 1 is 12. 10 plus 2 is 12. 9 plus 3, and on down the line. What plus 7 equals 12? Well, yeah, it's 5. Okay. So from that, I know that the first term would be f to the 5th power. Okay. So these two powers must always add up to 12. Since they're looking for the 8th term, the second one is 7. How do you figure out the coefficient? Well, this is where some of the stuff we've studied earlier about permutations and combinations of things comes in handy. These two numbers here, 5 and 7, will go on the bottom. And this 12 here will go in the top. I guess I should use the technical terms. The 5 and the 7 go in the denominator, and the 12 goes in the numerator. Now that's not 12 divided by 5 times 7. That is 12 factorial divided by 5 factorial and 7 factorial. Now, if you didn't have a calculator, that might be a little bit tedious, but you do have this very powerful instrument available to you. And if you will do 12 factorial divided by 5 factorial divided by 7 factorial, it will give you 792. And again, still f to the 5th power, s to the 7th power. All right? So, comes in very handy. Like I said, you don't carry a copy of Pascale's triangle around in your back pocket. You do carry your calculator. This is the third example in this lesson. It says find the 10th term of 2x cubed minus y to the 15th power. Several things are going to be going on here, but first of all, we're going to deal with how you find the coefficient and how you find the powers. Had this been f and s, or x and y, wouldn't be a problem at all. The fact that this is 2x cubed, and the fact that this is negative y, is going to throw some other things in it. So first thing I'm going to do is write down 2x cubed, put parentheses around it. I'm going to write negative y and put parentheses around it. And then there's room for my coefficient. Okay? Since I am looking for the 10th term, I know that my second term in the quantity will be to the, what is it? When I was looking for the 8th term, it was to the 7th power. I'm going to do 1 minus it. This number minus 1, I should say. So if I'm looking for the 10th term, this y is going to be to the 9th power. Okay? What is the power? The exponent of this 2x cubed? I don't know. What's 15 minus 9? What do I add to 9 to get 15? It's 6. So, the 2x cubed will be to the 6th power. The negative y will be to the 9th power. Both of those numbers go down here in the denominator. And they are factorial. 6 factorial, 9 factorial. In the numerator, 15 factorial. Now we still have to work this all out. If you do this, you will get this 15 factorial over 6 factorial, 9 factorial, gives you 5005. But that is not my final coefficient. Because if we look at this, this isn't just x cubed to the 6th power. This is 2 to the 6th power also. So this is 5005 times, well, what's 2 to the 6th power? It's not too hard. 2, 4, 8, 16, 32, 64. 2 to the 6th power is 64. X cubed to the 6th power. We know that when we have a power raised to a power, those numbers get multiplied. So we have x to the 18th. And this is important. This is just simply going to be negative y to the 9th power. That's negative y times negative y times negative y 9 times, telling me that my final answer is going also to be negative. Had this been y to the 10th power, my answer would be positive because a negative to an even power will become positive. All right. 5005 times 64 gives me 320,320. X to the 18, that's an 18 right there, and y to the 9. And again, I said your final answer would be negative. So the final answer is negative 320,320, x to the 18th, y to the 9th. That is the 10th term. Thankfully, they didn't ask us to do all 16 terms. That would have been incredibly tedious. Okay. Now we're going to go to the very first example. So I'm going to erase this here. First thing I want to say about the first example in there is that the book doesn't actually finish the final answer. They just kind of show you how to do it, but they don't give you a final answer. But it says to find the first 4 terms of the expansion x plus delta x to the 7th power. From that, I know if we were to multiply it completely out, we would get 8 terms. They're not asking for all 8 terms, thankfully. They're only asking for the first 4 terms. Okay? So what I'm going to do is my first term will be x to a certain power and delta x, or change in x, to a certain power. I know that it's to the 7 power and to the, not first power, to the 0 power. Over here, 7 factorial, 0 factorial, and over 7 factorial. Well, when we multiply this out, I actually didn't have to show all this work. I know my first term is going to be x to the 7th. Here I've shown the work. By the way, 0 factorial. Do it on your calculator. I ask students, what do you think 0 factorial is? And they say, oh, it's going to be 0. No, believe it or not, it's 1. More about that later. I don't have time to explain that now. But we have 7 factorial over 7 factorial, which is 1, and 0 factorial, which is 1. So we have 1x to the 7. Excuse me. And the delta x to the 0 power, anything to the 0 power, is also 1. So there's our first term. Our second term will have a coefficient here. Will be x to the 6th power. Delta x to the 1st power. Over here, 6 factorial over 1 and 1 factorial. On top, 7 factorial. Well, that's 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times. It's just going to leave us with 7. And x to the 6th. Delta x to the 1st power. There's our second term. Those two weren't too bad. Our third term, and I may have to drop it down here, I don't think I've got room on the other board, is going to be x to the 5th power, delta x, can't do the math real quick in my head, is to the 2nd power. Down here, we're going to have 5 factorial and 2 factorial, and again, 7 factorial in the numerator. That'll give me, by the way, I don't have that right here off the top of my head, but it'll give me x to the fifth, delta x squared. What is 7 factorial? That's going to give me, oh boy, caught myself flat-footed here. I didn't do this ahead of time. 7 times 6, that's going to be 7 times 3, that's going to be 21. Better check the book to make sure. Well, they actually, if you look in the book, they don't give the answer. They just have 7 factorial over 5 factorial, 2 factorial. Let me just do that real quick in my head again. 7 times 6, 7 times 3. Yep, it's 21. All right. How about the fourth term? I'm going to have to drop down here. The fourth term will be x. Well, let's do this. It's fourth term, so the delta x is going to be cubed. And we've got to add up to 7. This is going to be 4. This is going to be 4 factorial, 3 factorial, and up here 7 factorial. I may have to, I didn't do that one ahead of time. I'm going to have to think about this for a second. So, what is 7 factorial over, okay, so that's going to be 7 times 6 times 5 divided by 6. That's going to be 35. The last term is 35 x to the fourth delta x cubed. And they could keep going, but thankfully they said just do the first 4 terms. And the book has that delta x in parentheses each time. It's not necessary. And as I already said, they did not multiply these out. They just left them as these, like this, the factorial in the numerator and the denominator. Hope that wasn't too confusing. Look forward to seeing you guys soon. Hope you're having a good time with your families, enjoying your break. See you soon, and God bless you all. Call me if you need anything. Text me, email me.